Welcome to all. In the series of numerical analysis, we will study some concepts which are studied in numerical analysis. So when we heard the word numerical analysis, then we will be having, obviously we have one question that is called what is numerical analysis. We may have what is numerical analysis. So the answer is numerical analysis is a mathematical discipline concerned with the method of generating numerical solutions. Here the solutions are obtained in terms of numerical values. Here numerical values solutions are in terms of numerical values. So this is what it is nothing but what is numerical analysis. Next, what is we can see what is the aim. The aim of numerical analysis is to provide constructive methods for obtaining answers to problems involving continuous or discrete variables. Here we may be having some discrete or continuous values, then we have to find the constructive method so that we have numerical solutions. So that is the main aim of numerical analysis. Now we have one more question which may be why to study numerical analysis. Why to study numerical analysis? So this is because there are many situations where analytical procedures are either tedious or not existent. For example, if you have a polynomial of degree 5, something a naught x power 4 plus a2 x cube plus a1 x square plus a4x plus a5 is equal to 0, then we don't have any analytical procedure, so that we will be having the roots of this equation. In those situations we will be using numerical analysis techniques. Now we have to note one more thing. The solutions obtained by a numerical technique are approximate solutions. The solutions are approximate solutions which may be less than or which may be somewhat more than the exact solutions or the true values. Now in order to know the accuracy of solutions, it is essential to estimate error involved in them by comparing them with the true solutions if available with the experimental data. If suppose there are true solutions available, then we have to compare these approximate solutions with them in order to get the error involved. So error may be the value of the true value, the difference with approximate value. So this will be error. So in order to know the accuracy of the solutions, we have to compare the true value with the approximate value. By doing so, we can find what is the error involved in that particular numerical method. Now for that we have to study accuracy of numbers. So accuracy of number means there may be two types of numbers. Therefore there are two types of numbers which are exact and approximate. Now what are exact numbers? Exact numbers are those numbers which can be expressed by a finite number of digits. If there is a number which will be expressed by a finite number of digits, then such number is called exact number. There may be some examples. This 2, 4, 9, 6.45, 7 by 2, or maybe 1 by 2 and 9 by 2. So these are some exact numbers because which can be expressed in terms of finite number of digits. Now what are approximate numbers? Approximate numbers are those which cannot be expressed by a finite number of digits. So we cannot be expressed as a finite number of digits. So they may examples may be 1 by 3, 4 by 3, root 2, 1 by 3, somewhat, so on, etc. These are approximate numbers because they have so non-ending digits after the decimal point. So those are called approximate numbers. Now we have seen what are exact numbers and what are approximate numbers. Now we have to see what are significant digits. So significant figures or significant digits. The digits used to express a number are called significant digits. So the number of digits which are using in expressing the number are called significant digits. For example, so if suppose we have 7845, this involves 4 digits. So this is involving 4 significant digits are there in this. 4 significant digits are there in 7845. Now in case of 3.589, we have also 4 numbers. These are called 4 significant digits. Also in 0.4578, we are also having 4 significant digits because we are not counting 0 because 0 is helping only to fix the position of the decimal point. So this 0 is helping only in fixing the decimal point. Therefore these three numbers are having 4 significant digits. Now we may see some more numbers. So this is 7500. We can observe here we are having only 7 and 5 as a non-zero numbers. Therefore this is having 2 significant digits. Again 43,000, we can observe also here 4 and 3 are the only 2 non-zero numbers. Therefore this is also having only 2 significant figures or significant numbers because zeros help only in fixing the position of the decimal points. Now we will be having one more concept that is called rounding off. So what is rounding off? There are numbers which with large number of digits. So number with large number of digits, there may be numbers with large number of digits. The process of dropping unwanted digits is called rounding off. So large number of digits after the, so they may be large number of digits after the decimal point. So in such cases we have to drop some unwanted digits. That procedure is called rounding off of the given number. Now we have some set of rules for rounding off of a given number. So we will see that rules to find rules for rounding off a given number into n significant digits. N significant digit means they will be having only n digits after the rounding off. Now what we have to do? Discard all the digits to the right to the n digit. Suppose we have some 5.8345. If we want to round off the number into some 4 significant digits or 3 significant digits after decimal point, 3 significant digits after decimal point. So 834 is a 3 significant digits. Then we have to discard all the digits to the right of nth digit. So this is the third digit. So discard this 5. If the discarded number is less than 5, leave the n digit unchanged. If it is less than 5, if suppose we have 6.8342. So significant digits, 3 significant digits after decimal point, we have to just discard the n plus 1 digit. If the discarded number is less than 5, leave the n digit unchanged. So this will be 6.834 only. If it is greater than 5, if it is like 8.34 and this is 7. So after this 4, 7 is greater than 5. If it is greater than 5, increase the nth digit by 1. So we have to increase this by 1. So that will be 6.835. Now if it is equal to 5, increase the nth digit by 1 if it is odd. Otherwise leave it unchanged. Here we have 5.834, 5.8345. So you can observe we are supposed to have 3 significant digits after decimal point. This is the nth digit, means it is a third digit. So after this it is a 5, it is equal to 5, and the number nth place number will be 4, which is not odd. Therefore we have to leave as it is. This is 5.834 is the number which is rounded off to 3 significant digits after the decimal point. Now we can see some examples so that it will be clear. The following numbers round off to 3 significant digits are. So we have given some numbers. We have to round off to 3 significant digits. So 3 significant digit means in the number we have to have only 3 numbers. So 3 digits in the number should be there. We are not talking about after the decimal point, but totally we have to have 3 digits should be there. So this has 7.893 has 4 digits. We have to make it as 3 digits. So 3 digits mean 7.89. So you can observe the number after 9. So this is less than 5. Therefore we have to leave 9 as it. Therefore it is 7.89. Here also. So 3 will be this. So after 8 it is 6. It is more than 5. So add 1. It is 12.9. Now for this, so 3 will be here. So this is after 3, 1, 2, 3 digits. So after that it is 5. So it is equal to 5, and the third digit is 3. It is odd. Therefore increase it by 1. This is 6.44. Here also 3.6. 7 is more than 5. Therefore we have to add 1 to 6. 3.57. Now here this is 5. So after the third digit 5, it is 5. So which the third number is even. So we have to leave as it is. This is 5.8. So these are some examples for rounding off, which is having 3 significant figures. So totally 3 figures should be there. Don't worry about the decimal point. It should there be only 3 digits. Now the following we will see some more examples. Following numbers round off to 4 decimal places. We have to 4 decimal places. So after decimal point we have to have only 4 digits. This is 1, 2, 3, 4, 5, 6 digits. So 6 digits are there. So we have to don't worry about the 3 digits after decimal. We have to check with the 4th and 5th. So it is 5, and the 4 digit is odd. We have to increase it by 1. This 4. Here also, so 3 digits we have to write as it is, and the 4th is 6 and the 5th is 5. So it is 5 and it is even. So we have to leave as it is. Here also, so 3 digits we have to write as it is, 12.464, and 4 digit is 7. It is 6. It is more than 5. We have to add 1 to this. So this is how we can find the rounding of the decimal rounding of the number after the decimal places. We have to remember whether it is two decimal places or to only to some digits. There may be some corrected to some n significant digits, which implies there should be n digits in the whole number, in the complete number, if there are correct to n decimal places. N decimal places means after decimal point n digits should be there. So there will be slight difference between these two. You have to observe that very keenly. So this is about correcting to the rounding off to some significant digits or some decimal places, some n decimal places. Now we will be seeing types of errors. There are some 2 to 3 types of errors. Those are inherent errors, rounding off errors, and truncation errors. So what are inherent errors then? The errors which are already present in the statement of a problem before its solution. So before the solution we will be having one problem, which is, suppose it may be f of x is equal to 0. If suppose this function involves some any error, any mistakes in this, that will lead to inherent errors. So this can be removed by taking the correct data. So if you take the correct data, so then these inherent errors can be removed. Now rounding off. So there may be errors due to rounding off of numbers. So this can be removed. By taking more number of digits after decimal places. More digits after decimal places, or taking more significant digits, So what are rounding off errors then? The errors due to rounding off numbers during the computation process. When we are finding the solution, then we can round off the given number to some other number which is having less significant digits, then which involve the errors. Those are called rounding off errors, which can be removed by taking more digits after the decimal places or taking more significant digits. So this can be removed with the help of these two options. Now truncation errors. So these are the errors which are caused by truncating the numbers. Truncating means chopping the number after certain place, chopping the numbers. For example, so if this is truncated to, if the given number is truncated to, if it is truncated to 4 digits, then we will be having only writing 4 digits. So if the number 13.65 is truncated to 4 digits, then it involves only 4 digits, and after 5th digit everything will be deleted. Here it is, if it is truncated to 6 digits, then it will be 8.88521. So we are not rounding up, we are just dropping out the other digits. So this is about truncation errors. This can be removed by taking more number of digits after the decimal point, or taking more number of significant digits. This can be removed by taking same procedures. Now we have to measure error. So till now we have seen how error is occurred, but we are supposed to measure them. How to measure them? So there are some three measurements from which the error can be measured. The one is absolute error in terms of relative error, and one is percentage error. What is absolute error then? It is nothing but the difference between the true value and the approximate value. So this will give the absolute error, or we can write it as true value may be exact value, that is xe, approximate may be xa. So xe means exact, means true value, exact or true value, and xa is approximate value, which may be obtained with the help of numerical technique. Now relative error. Relative error is nothing but, so this is nothing but the ratio of true value minus approximate value divided by true value. So we can write in terms of x as, this is xe minus xa by xe. This is nothing but relative error. Now percentage error. So multiplying the relative error by percentage, 100 will be percentage error. This is xe xa by xe into 100. So this will be percentage error. We can write it as relative error into 100. relative error into 100 will be percentage error. This is how errors can be measured. So one is absolute error, relative error, and another one is a percentage error. Absolute error will be the difference between exact value and approximate value. Relative error will be ratio of the it can be ratio of absolute error to the modulus of x value. So this will be relative error, and percentage error will be the multiplication of relative error with the 100 will be percentage error. Now we will see one more thing, that will be accuracy and precision. So what is accuracy and what is precision? Now accuracy means accuracy measures how close a measured value is to the actual value. So if suppose we have one exact value, it is xa. If the difference between xe and xa is very less, if it is very less, it is 0.00 something, so these two are very close, then difference is very less, then those two are said to be accurate values. So this xa will be more accurate to xe. So therefore accuracy measures how close a measured value is to the actual value, and accuracy is the closeness of a measurement to the true value. Here also we can note one thing, higher the accuracy, lower the error. So if it is more accurate, the error will be less, if it is more accurate. Now precision is nothing but it is the closeness of the multiple observations to one another. If suppose we are having xe as the exact value and x1 and x2 are the two observations which are approximate values of xe. If suppose x1 and x2 are very close, x1 and x2 are very close, then this observation is more precise. If x1 and x2 are somewhat, if x1 and x2 are far, or that is x2 minus x1 minus x2 difference is more, then they are less precise. This is about accuracy and precision. Accuracy is nothing but comparing the observation with the exact value. Here precision is nothing but comparing the multiple observations with one another. If the two observations are very near, then they are said to be more precise. If the two observations are very far, then they are said to be less precise. Now we will see one question on the concept of accuracy as well as precision. So which is a question of CSR net December 2019, which has been asked in Patak section. The question says the length of a rod is measured by two persons. Person A reports the length to be 1002 plus or minus 1 centimeter, while person B reports the length to be 1001 plus or minus 2 centimeter. It is known from a more reliable method that the length is 1000.1 plus or minus 0.5 centimeter. Then which of the following statements is correct? So there is a rod whose length is to be measured, and that is measured by two different persons, person A and person B. Person A reports to be 1002 plus or minus 1, person B reports it to be 1001 plus or minus 2, and the actual length will be 1000.1 plus or minus 0.5. Then they are asking which of the following statement is correct. So option 1 says measurements made by B are less accurate but more precise compared to those by A. A are less accurate but more precise compared to those by B. Measurements made by B are more precise and more accurate compared to those by A. And the option D is measurements made by A are more precise and more accurate compared to those by B. So we have some accuracy and precisions between A and B. So we have to see first how to do that. So the exact length they have seen as 1000.1 plus or minus 0.5. It has values 1000.6 and that will be 1000.1 0.5 6 999. So this is 99.6. So therefore the rod length may be 999.6 to 1000.6. So this may be between these two values, or from this value to this one. The rod length may be 999.6 or 999.7, so on, maybe up to 1000.6. Now observations from XA will be 1000 1002 plus or minus 1. So those will give 1001 and 1003. So the length may be from 1001 to 1003. Next XB will be 1001 plus or minus 2. This will be 1001 plus or minus 2. This will be 999 and 1003. So the length will be between 999 to 1003. So we can just observe. So XA value, suppose it is XA1 and this is XA2. So the difference between XA1 and XA2, this will be 2, and the difference between XB1 and XB2, XB1 and XB2, this will be 4. So we can observe XB1 and XB2 values are having difference 4, and XA1 and XA2 values having difference 4, which mean that XA1 and XA2 are more close compared to XB1 and XB2. Therefore A is more precise, means they are more close, the multiple observations are more close. A is more precise. And compared to accuracy, so the exact value will be lying between 999.6 to 1000.6. So here you can observe XE, this will be 999, this is 1003. So if this observed with XA values, so it doesn't have value which is below 1001. So therefore this 999.6 value is not included in this XA value, but it is included in XP values. So this 999.6 to 1000.6 is included in 999 to 1003. So therefore this is for B. So B is more accurate compared to A. Therefore A is more precise and B is more accurate. So we can check with the, so B is more accurate, A is more precise, and A is more precise, more accurate. This is not B is more precise, B is not having both. So A is less accurate but more precise compared to this B. So A, we have A is more precise. So this has A is more precise. So this has, so less accurate. There will be are less accurate but more precise. B is more precise, but B is not more precise, but A is more precise. So therefore this is not, this option goes A is more precise and less accurate, because B is more accurate. B is more accurate means accurate implies A is less accurate. Therefore option 2 is the correct option. So this is how we can solve the problems on accuracy and precision.